everyone. Thank you so much for joining us. My name is Ashley Koff, a registered dietitian and founder of the Better Nutrition Program. And first and foremost, I want to say thank you so much to Fullscript for being a destination spot for us in all of our businesses, not just to help us implement total nutrition recommendations more easily and effectively for our patients, but also as a place to just have this caliber of education that both my colleague Amanda and I are so privileged to be a part of today. A little bit of housekeeping. This is science heavy. That we're gonna geek out a bit, and just wanted to make sure that you know that we intend to go through it and allow for a couple of minutes of Q&A at the end, but we have also arranged for 2 additional question and answer periods, one live tomorrow in a Facebook room, and then the other on Thursday in a Zoom room. And Kaylee will be sharing that in the chat box. She'll also be sharing a link where you can preview the tool that we will be talking about in the second half of the conversation. And then if you have any questions or want to share anything in the chat regarding any issues with sound or anything else like that, she'll be there to answer that during this. And also, as I mentioned, we will take your questions and either be able to answer a couple of them today, or we will would love to invite you to the sessions tomorrow, which will also be recorded. That was my other point. All of you will receive access to the recording, and that will come later this evening, as well as via email in the next couple of days from the Better Nutrition Program. Okay, so today we are here to discuss the gang of B vitamins plus what I like to call cousin choline, from assessment to personalized recommendations. And it is my privilege to collaborate with Amanda Archibald, principal from the Genomic Kitchen, to share in this conversation today. So let's dive right into it. The learning objectives for today, we want to make sure that we're defining the essential role of B vitamins, and specifically a few vitamins that we're calling the gang of B's and choline in better health outcomes. We're also going to have you understand how to optimize personalized recommendations and understand how that is your competitive advantage as a practitioner. If you can, take a moment and just let us know what type of practitioner you are. If you want to drop that in the questions or in the chat box. The question box would be great for us. That's always helpful to make sure as we're going through that we educate specific to your area of expertise and scope of practice. And then we'll share with you some additional resources, as well as an incredible bonus where you will have both access to the tools and also a significant discount for the tools and a private access to an exclusive genomics practitioner program. We'll be talking about that at the end, so stick with us. About us, we've shared our bios and they're available, but key things to look at. We've both been doing this for a really long time, and we've been doing it at the global level. And if you want more information or to connect with either of us, you can do so through our companies. And then about you, this is really important. Why are you here today? As healthcare practitioners, we don't have one goal. We don't have just a profitability or a revenue goal. And in fact, we have this super, super important, why are we doing what we're doing? Why are we in continuing education, et cetera? We want better client outcomes. And so today, what we will have, today's presentation is going to show you how we will help you achieve both of these goals better. We want to make it easier for you to deliver and to compete in this very competitive, in some places saturated marketplace for personalized recommendations and products being sold as personalized, but they are not. And so we want to help you compete with truly personalized medicine, personalized nutrition. Everyone is selling this that's out there, but few are actually doing it. But with the right tools, namely you and your training, as well as the tools we're going to show you today, you can and you should be harnessing the power of personalization as your competitive advantage. And by personalizing, we're going to talk about specifically today what that looks like with your gang of B vitamins recommendations, and also the trusty sidekick, choline, and why it's so important for us to understand choline's essential role, not just for pregnancy, but throughout life stages and for each of our individual clients. So with that, I'm going to turn it over to Amanda to go ahead and get started with and I will be doing the slides. I'm Havana. So go ahead, Amanda.
Hi, good afternoon, everyone. I think every time zone is in the afternoon here in the United States, and happy spring to everyone too. So my principal goal here as part of the conversation with Ashley is to dive deep into B vitamins. For some of you, you're very, very familiar with what I'm going to be talking about, which is the folate to methylation cycle and how the B vitamins are so essential to informing what I call the heartbeat of our biochemistry. So for those of you who can kind of zoom along, this is just going to be a great review, and you may have something to add in the chat. For some of you, this is going to be the biochemistry we should have all learned in school and wish we did, and it's amazing. And you may think that you're going to be drinking through a fire hose. Don't worry, it takes a long time to get this into your head, which is why we have the breakout to the Facebook groups, et cetera, et cetera. My current intern asked me yesterday, and we'll jump in here. She said, how do you learn all this stuff? Are you self-taught? And I said, in this field, we start with where we begin, where we learned at university or what have you. And then we take additional courses, and then mentorship is so, so important to understand this. And then through mentoring and curiosity, you go back out to the literature and you say, I want to learn more. And you do learn, you do you do self-teach, you learn from others, you get mentored, you come back and you repeat it. So that's essentially how we all learn. So on that note, let's get into the gang of bees. Ashley, I'm the sidecar, she's the driver here with the slides. So to me, as you heard, the gang of bees lies at the heart of human biochemistry. And I say this because my work is in nutrigenetics and nutrigenomics. So I'm looking at how genes basically are the signposts that is guiding us where to look in nutrition science and nutritional biochemistry. So the gang of bees, the B vitamins, deeply impact the folate cycle and methylation cycle, which is where we're going to focus today. But collectively, the folate cycle and methylation cycle then inform the transsulfuration pathway, which we'll look at here very, very briefly, and also the biopterin cycle. So these four cycles together are interlinked. I look at them like interconnected traffic circles, or if you think of gears or cogs in a wheel that turn each other. Everything works together, nothing works in isolation, and the B vitamins and cofactors are kind of the glue that sticks these cycles together. If you ask, I would say in the majority of my clinicians, what we learned about B vitamins in school, it would be their role in the Krebs cycle or energy and metabolism. That's usually what gets the most attention, and yet what we really want to focus our attention are the cycles that actually will produce the metabolic intermediaries that go into the Krebs cycle. So a lot of times we get focused there, and yet the really important stuff I would say is almost outside of that cycle. B vitamins are also very, very integral to digestion and microbiome balance. We're not really going to focus there today. So let's jump then to the beginning, Ashley. And Ashley, you keep me on track here. So the B systems, I've already kind of highlighted this, but what is their impact? Deep impact, as you're going to see when I kind of move on a couple of slides, in DNA synthesis and repair. But what I want to highlight there is look at the kind of cohort of B vitamins and their mineral cofactors that are integral to DNA synthesis and repair. It's a slate of them. Methylation, that production of methyl groups, the biochemical hooks that is so important for as epigenetic regulators or basically managers of gene activity. What are the B vitamins that are integral to the methylation cycle? And there you see the basket of B, the gang of Bs, magnesium and choline. And so on and on. The B vitamins, again, we're focusing kind of on folate and transsulfuration, but they're integral throughout multiple cycles and systems in the body. And when you start digging into genomics, you realize just how much we've missed in talking about B vitamins and how much we need to know. That's where we're going to head today. So next slide, please. So as you've heard me say, and I will say until the end of my career, the folate and B12 are probably the heartbeat of biochemistry. And biochemistry, the way I explain that to my clients, is your biochemistry or nutritional biochemistry is our human operating system. It's how we work. It's our circuitry, like a circuit board in a smartphone, or in our, those of us who are old enough to remember what a circuit board looked like in our computers. So it is with our nutritional biochemistry. It's the circuitry that helps us and makes us operate. All right, so let's begin at the beginning with folate. Back a slide. You were just handy with that today. So let's begin with folate, because folate gets a lot of attention and there's a lot of hysteria around it because people kind of grab onto, as you can see here in this slide, MTHFR. But let's start with why folate is so important. Again, a review for some of you, and for others, this is like, wait a minute, I sort of know some of this, but remind me. So let's talk from a food perspective first. That food in folate is best, folate in food is probably the best form of folate we can access. But to get folate into a form that the body can utilize requires a number of steps, which we're going to look at. So the folate in food is actually in we call it a polyglutamate form. What that means is for the body of cells to be able to utilize folate, those glutamate residues, this molecule, if you will, has to be hydrolyzed into a monoglutamate form. So if you, Ashley, if you just kind of point to the left-hand side of the slide, I've got this orange box. It says the only way the body can utilize folate in food is it has to be hydrolyzed into a monoglutamate form that can then enter into the enterocyte, as you can see here. So this hydrolysis this enzymatic process is zinc dependent. And I like to highlight that because everyone thinks of zinc. We think of zinc as being involved in so many different reactions in the body. Immune. Well, guess what? For food folate to get into the cell, it requires zinc. So right there, we have a rate limiting step. So once folate enters into the enterocyte, it's in the tetrahydrofolate form. So you can see that central molecule, THF. That is then biotransformed into 5,10-methylene tetrahydrofolate, which is then grabbed by the infamous MTHFR enzyme, and it's transformed into 5-methyl tetrahydrofolate. So one of the major objectives of the folate cycle, one of the major ones, but not the only one, is to get folate into its methylated form so that it can then interact with the next step, which is the methylation cycle, which we're not going to right now. So here's what comes up a lot. As you can see at the top of the slide, and it'll come up in the chat, no doubt, or in our convo tomorrow in our Facebook group, is folic acid. So folic acid is ubiquitous. I don't think in this group of clinicians we need to discuss so much about it, other than take a look at this. Folic acid can basically diffuse from the enterocyte into plasma without being biotransformed. In other words, it's passed through in an unmodified form. And what are the implications of that? We'll look at that in just a moment. Some of you already know them. But note here that folic acid has to go through a two-step biotransformation process via DHFR, dihydrofolate reductase. So it's a two-step process, and that process is extremely slow. So if we're relying on folic acid to up our folate levels, it can take a long time. And it can kind of gum up the work. So think of that in terms of, how we're trying to get food into the body or nutrients or cofactors into the body. Folic acid is it's a slow process, okay? All right, on to the next. We are going at pretty much a breakneck speed here today, so do join us tomorrow or join us with questions. Let me make it very clear that the image you're looking at here is sourced from Bioceuticals in Australia. They have a fantastic program, DNA Training and Practice, that's taught by my good colleague, Dr. Denise Furness. And as she was teaching, she used these images from Bioceuticals, so very, very clear that I didn't come up with these. So what you're looking at the left-hand side is the folate cycle, and in the middle, how that basically interacts with vitamin B12 and homocysteine to drive the methylation cycle. So look again, and Ashley will actually drive this with me with her pointer. So what we're seeing here is that folic acid, and we could add also here folate or food forms of folate. The goal is they end up in the intermediary form tetrahydrofolate. Tetrahydrofolate is then biotransformed or transformed by MTHFR, which we'll be looking at the end of the presentation, into the 5,10 methylene tetrahydrofolate form. Note we're not in the end stage yet, we're in an intermediate form there. So that is a really important jump off point, as many of us know, because 5,10 methylene tetrahydrate is kind of the portal into thymidine, purine, pyrimidine synthesis. So the bottom line is that's the jump off point, the preferential point for DNA synthesis and repair. That's one of the major focuses, if you will, in simplistic terms for us, of the folate cycle. If we're not directing folate into DNA synthesis and repair, we've got a little label that's covering this. My point, my issue there, Ashley, is underneath that little label there is MTHFR. Whoops, it's okay. There it is. Oh, no, it isn't. It doesn't matter. So underneath that, we'll see a little later, is MTHFR. So 5,10 methylene tetrahydrofolate in conjunction with riboflavin B2 is transformed to 5-methyl tetrahydrofolate. There we have the other, if you will, end product or destination product for the folate cycle. What's going to happen with this particular molecule? It's going to give those methyl groups, say carbon and 3 hydrogens, to go to homocysteine. So if we jump over to the next cycle, those methyl groups are basically in conjunction with B12 provided to homocysteine, I'm making this very simplistic, to recycle methionine. So one of the major points of the folate cycle is to produce those methyl groups that will give them to homocysteine to simplistically recycle methionine. Methionine is then biotransformed in conjunction with MAT1. It's a magnesium-dependent enzyme to produce S-adenosyl methionine, SAMe, which is, as we know, our master methyl donor. So I think if we just stand back here, and I guess we're going kind of at lightning speed, what you're seeing here is if you look at the B vitamins, the B3, if you go back to folate, so niacin, is a cofactor for MTHFR. B2, so riboflavin, is a cofactor for MTHFR. That's kind of hiding underneath the little label there. And another route that you can look at to transform tetrahydrofolate to 5,10 methylene tetrahydrofolate is the enzyme SHMT1. That is B6 dependent. If you're trying to hand the methyl groups from folate to homocysteine in conjunction with B12, or to, if you will, to B12 to recycle homocysteine or recycle methionine, you see that that's zinc dependent. So you see that when we're looking at food and we're kind of creating recipes or we're talking about targeted food, there's a gang of nutrients that we need to actually facilitate the heartbeat and the flow of human biochemistry. So just these two cycles, which we're going through pretty fast, you can see where the gang of B comes in. I'm going to point out one more thing, Ashley, then we'll move on. If you point to homocysteine, homocysteine has two destinations. It can either be involved in recycling methionine, that's how we can generate our methyl groups. There's a different route too, that's how we can generate our methyl groups. But also homocysteine sits at the headwaters of the transsulfuration pathway. And one of the end products there is glutathione. You produce taurine, pyruvate, lots of downstream metabolic outputs. But see that homocysteine requires B6 to enter into that transsulfuration pathway. Super, super important. So you know what we're going to do here, Ashley, I'm actually going to talk about choline here because I know it's one of your favorites. It'll come up later, but let's, in the interest of time, talk about choline here. So, and then we'll come back to it too. So what you're seeing here is choline in the center of that methylation cycle it's kind of like you see there's an arrow, and it's like I call it the frontage road or a side door, or it's like, you know, an escape route. I live in Colorado, and way up on Vail Pass, you know, it's a really, really steep path. And we have these runaway ramps for trucks. This is like the runaway ramp, you know, when you're on a steep decline here. So what happens then when you have a deficiency in folate, or there's inefficiencies in the folate cycle, or you're deficient in vitamin B12, the body still needs to produce methyl groups, okay? So one of the ways that it can do that, because methylation is so integral, the methyl groups are so integral as a hook throughout reactions in the body's super smart. It's a brilliant biochemical machine. That's the way I look at it. So the body has another way to recycle methionine and produce those methyl groups, and it's through betaine and it's through choline. So betaine, it's just mainly a process that occurs in cells in the liver. Betaine you find in beets, you find it in quinoa, you find it in amaranth, spinach. So these are really important foods that we want to stack in the pantry and see if our clients are eating them, because they're a side door food. So betaine basically is a source of trimethylglycine, TMG. Here you're hearing the methyl groups again. So betaine basically is an alternative methyl donor. Choline, which we find in eggs, we also find it in whole soy, sunflower seeds, and some other foods. You know, nature's gift are eggs, right? But eggs are not eaten by everyone. Choline, through choline dehydrogenase, can be basically biotransformed into trimethylglycine. I'm saying trimethyl, and there's something says it's dimethyl, but the bottom line, it can be transformed into a methyl donor as well. And you've got this escape route, you've got this alternative route. Note again that zinc is integral to that choline reaction. So look here, if we just stand back and we said nothing else, can you see how the gang of bees is so important to the heartbeat of human biochemistry? That's what I call these two cycles. They're attached to so many others. You've got your bees, but I keep mentioning zinc. And if you point up to the space between methionine and SAMe, that is a magnesium dependent reaction. So the heartbeat requires a number of core nutrients, facilitated mostly by B vitamins. Okay, Ashley, so the question comes up, what about folic acid? And, you know, I think we could spend probably hours talking about folic acid. Jot down this research article because it's very useful. It's called Circulating Unmetabolized Folic Acid, the Relationship to Folate Status and Effect of Supplementation. If I draw your attention really quickly to the left-hand side, because it relates to the next slide, you could see I pulled out a couple of quotes from this particular research article. The researcher said, in summary, this work, so the work they were looking at in research, corroborates and contradicts current and common views on folic acid metabolism. For instance, hepatic DHFR, that's our rate-limiting enzyme, activity in humans is considered to be highly variable but universally slow. So I pulled that out because it represents this kind of ebb and flow and yin and yang in how we understand the impact of high levels or elevated levels of unmetabolized folic acid. Some researchers are going to say it doesn't have an impact. Other researchers say, oh, yes, it does. And that's the camp definitely I'm personally following in the literature, which suggests high levels of unmetabolized folic acid actually have an epigenetic impact. So they may be down-regulating, or basically shutting down tumor suppressant genes. This is some of the more recent research. And that I emphasize in the next slide. We'll move on to that one, Ashley. We can probably send out these citations as well. And here to the point that the dihydrofolate reductase enzyme can be extremely slow. And if you have a SNP or a variant on that, it can be even slower and even more inefficient. And yet we have people eating high amounts of folic acid found in foods. They may not be taking a supplement, or maybe they are. And yet, if we don't know their genetics, they could be walking around with very high levels of folic acid. It appears their folate levels are normal, depending on how we're testing, right? And yet those levels, folic acid in that form, can actually be having an epigenetic effect. And that is what we're starting to learn. There's been very, very interesting research related to cancer and high supplement intake, and particularly high intake of folic acid, supplement or food driven. All right, so where are we? What about MTHFR? So what you're seeing here, because this comes up all the time, I'm hearing it from clinicians, and of course, if you're listening, if you're sitting in on Facebook groups, I have MTHFR, and then you can complete the sentence, which means A, B, C, D, E, or what do I do? Basically, as you've seen, and we didn't even go into all the genes, there's a lot of genes up and downstream from MTHFR that we consider clinically when we evaluate whether MTHFR is at play. A gene can be at play, but until you validate it through laboratory testing, you don't know, you're guessing. So what you're looking at here is a calculation from my colleague, Denise Furness, again, presenting through Bioceuticals in Australia, so this is absolutely their work and not mine. It's a calculation through the literature of what happens when you have these different combination of alleles. So yeah, you can have MTHFR 677 and 1298, and if you have homozygous CC and homozygous AA, no impact on the enzyme activity. It's when you go down and you have different combinations. This is where bioinformatics is so amazing to me. If you have the TT version of the 677 MTHFR gene and the AA of 1298, you're looking at a more significant reduction in enzyme activity, but you have to validate that, okay? Just because your genes suggest that there may be a deficiency or an inefficiency, it is not so until we validate it in laboratory testing. Assess, validate, implement, reassess. And you have a way of saying that, Ashley, and you can unmute yourself, but you have a way of saying, this is how we do this. It's like a 3-word, da-da-da.
It's coming up in it'll be coming up in our next section, but I call it ACT. So it's A stands for assess, C stands for choose, T stands for track. So if we want our patients to get better, we need them to, we and they need to act better. And so we'll go through this. Yes.
Okay, good. All right, so so that's MTHFR. Again, all we're doing in this webinar is talking about the gang of bees. So on that note, so you can kind of see where I'm going, that this basket of bees is super, super important. And we're just looking at 2 cycles. So then let's look at B12 then. You ready? Yeah, Ashley, like I said, she's the driver. Go back one. There we go. So we've looked a little bit at B12 already here, but what I want to kind of pay you to circle is that we know how integral B12 is to the methylation cycle, because it is at that intersection, like a Venn diagram between 5-methyl tetrahydrofolate and homocysteine. You know, this whole process does not work without all the nutrients being present and at play. But B12 is kind of interesting, as we're going to see, is that yes, we can synthesize it, but is it in a form that the body can utilize? And given the state of the guts of many of our clients, we probably can cross that one off, right? This comes up a lot. But a couple of genes are really at play that impact the availability of B12 and absorption and distribution to the body. And one is FUT2, FUT2, you can see at the top there, and the other is TCN2. So here's what's interesting. Next slide, Ashley. What's interesting is FUT2 is a gene that many testing companies will look at, both, as I said, TCN2 and FUT2 impact absorption. Here's what's super interesting. So FUT2, the gene, I call it FUT2, FUT2, what it actually does is it adds a fructose molecule to a galactose molecule to form an to form the H antigen that you'll be familiar with in terms of blood typing. But more noteworthy, and this is where it's science is amazing, is if you figured it out, you stick a fructose to a galactose molecule and you basically produce an oligosaccharide that is food fodder for the microbiome. And this is where the idea of secretors and non-secretors comes from when we look at the FUT2 gene. If you are a secretor, This means that oligosaccharides are serving as a food form for bifidobacteria. And so they're utilizing the B12 in that way, or the gene and the information from the gene in that way. And it means that you may have a far robust microbiome, but you have less B12 available for absorption. So secretors in general may have a better gut health. This is absolutely a generalization for us, but you may have lower plasma levels of B12 because the gut bacteria are both producing and using B12 at the same time, a robust gut bacteria. Non-secretors have a higher plasma B12, and as a result of that, they have a lower H. pylori risk. This is where it's coming from, because the gut isn't necessarily using the B12 within the gut. It's being able to be released for utilization, released to the plasma. But that oligosaccharide is not available, or less oligosaccharide is being produced and available to feed the microbiota. And so it's really interesting. So with non-secretors, we often really do see a higher risk for dysbiosis or gastrointestinal imbalances. I can almost say, because I look at a lot of DNA, every time I see that non-secretor, I'm going to ask, any gastrointestinal issues? It is very true. It's not always true, but it's often true. We often see that in clinical practice. All right, so that's kind of a nice little aside. So next slide. So we kind of know then that what is the impact of a lower B12 on biochemistry? Lower B12, when we're looking at methylation, means that there can be a slowdown in the methylation cycle, a little bit of a backup, less ability to form SAMe. The protein synthesis there relates to creatine. The creatine synthesis, and I learned this recently, is that about 70% of the methyl groups that are synthesized are pulled into creatine synthesis, where 30% are available as methyl groups to be utilized throughout the body. It was an amazing observation. Who knows where I've been to have missed that exciting fact. But the other issue, which we'll end on in a few slides here, is that many things can impact homocysteine. But if we have a lower folate, lower levels of methylated folate, or lower levels of B12, there is a much higher potential to have a high level of homocysteine, unless we can pull homocysteine down the transsulfuration pathway. In other words, homocysteine has two fates. It's either recycled to methionine, requires folate and B12, or it's pushed down the transsulfuration pathway, and there we need B6. Okay. Hopefully you get, even if this is sort of like, way, this is super fast, you get the point about why we call this a gang of bees. So what do we do about B12? These are some notes and observations I take just to pay homage here to Dr. Dan Sickler from Apeiron Epigenetics. He's a brilliant man, brilliant MD, teaching in epigenetics. And one thing he said about B12 is assume everyone is insufficient. He probably said deficient. Ashley and I say insufficient. And depending on the dosage, they may still be insufficient because of absorption rates. So there's a difference between oral and sublingual. Clinically, you all know that. In terms of the different types of B12, so cyanocobalamin is the cheapest. But one thing, we don't have time to go into today, but one of the things we have to think about with the cyano form is that we have to remove that the cyanide molecule. And if your clients have compromised detoxification, that can really gum up the works. Obviously not a focus for today, but just a note, the hydroxycobalamin form is the most user-friendly and produced by bacteria and found in the body. Methylcobalamin is, of course, the most active form. And adenosylcobalamin, we get a lot of questions about that. The methylcobalamin form does not bioconvert to the adenosylcobalamin, which is often the more expensive form. And the adeno form of B12 is really, really important to how we take the acetyl-CoA molecule and transform it. It's the last step of transformation into the succinyl moiety or molecule that is sort of at the gateway of the methylation cycle. So the adeno form we'll often use if a client is not responding to B12 and still fatigued. Okay, Ashley, that we need to go into in the Facebook group and question and answer, talk about that, because I kind of breezed over that, but it's a really important question that comes up a lot. All righty, so what to do about B12? A lot, and it depends on how the patient presents, what the biochemistry is, what the goal is that we're trying to do to achieve by restoring the inefficiencies in a patient's biochemistry. All right, Ashley. So what about choline? I call it choline and the methylation side door. So I should go to the next slide, Ashley, because we talked about this already. I jumped ahead. So basically, I showed you the side door here, that choline, the body is super brilliantly smart. And regardless, most people, and most of us are not working with DNA, so we would not know where to look. We're not necessarily going to see the inefficiencies. And if we're not using advanced testing, we may not even have choline available to us. So if you take a step back and say, I don't have any of this information, what you're looking at here is the biochemistry that informs what needs to be in somebody's grocery cart, what needs to be in their pantry, and what they need to eat on a routine basis, because the information in food is driving our innate biochemistry. It's driving this heartbeat of our operating system. So just wanted to kind of make that point, and we'll probably come back again to that. Okay. And Ashley, if I missed something, let me know, but next slide. Oh, there we are. Oh, it's the aha. Thank you. You would probably, if I didn't mention this, you would jump in and say, Amanda, you have to talk about this. So looking again, you've seen this over and over and over again, and you start to dream this stuff. Trust me, somebody will say, oh yeah, I get it. I wake up thinking about MTHFR. So here's the thing, that why choline is so important and why we have to counsel our patients on this huge basket of food. You see there that MTHFR is integral to the transformation of THF, tetrahydrofolate, to 5,10-methylene tetrahydrofolate. Preferentially, if you think about it, if there are SNPs, if there's blockages, or if they're to push folate biotransformation forward, it's going to stop here, or it's going to get hung up at 5,10-methylene tetrahydrofolate. Why? Because the body preferentially is going to want to synthesize DNA and repair it so we can replicate ourselves, so we can grow, so we can repair tissues, etc. What happens then is, if everything is shuttling preferentially to DNA synthesis and repair, the body still has to produce methyl groups. The methylation cycle goes on. We still need to produce proteins and creatine over on the right-hand side. So a lot of times we'll see a deficiency, or what am I trying to say here, a variant that impacts MTHFR. So things get hung up over there. You're going to see inefficiencies in MTHFR, so you're not going to drive that methylated form of folate forward. So what happens here is the body's like, hey, wait a minute, we need to produce methyl groups. So what is it going to do? It's going to pull on betaine and choline, okay, as a side door to produce those methyl groups. So this is all great and good, or it's wonderful, until we have choline deficiencies, and then which is frequent, right? There are many nutrients that come up as being deficient, but choline is one of them, selenium is another. And so can you see here, if the body is shuttling folate into DNA synthesis and repair, and it's not shuttling as much into the methylation cycle, then we are leaning on choline as a cofactor or a nutrient to kind of restore the methylation cycle. So it's super interesting to observe that. So what do we do? What can we do to shore up the core of our biochemical operating system? And then we have one more pretty cool aha over this. As you've probably seen at breakneck speed here, we want to ensure an adequate supply of folate to support the production not only of methylated folate, but also that 5,10-methylene tetrahydrofolate, because these forms of folate support, core cycles or core pathways in the body. You also can see we need an adequate intake of foods that are rich in B12. B12, as I say to Ashley, and those of you who are pulling labs on a regular basis, B12 is just inherently insufficient, as is folate, and I would say B2, riboflavin. We want to ensure an adequate dietary choline, or alternatively, ensure adequate food sources of betaine. So here you're looking again at amaranth, spinach, chard, beets, quinoa. All of these belong in our core basket because they're doing heavy lifting in core biochemical cycles. Okay, so just sort of ending up here, there's one final gem for you. And I'm actually going to have you stay on this slide for me, because there's one final slide, but I'm going to have you stay here so I can tell the story. So what you're looking at here is the final gem. Remember that DHFR gene. So DHFR takes folic acid and it transforms it into tetrahydrofolate, which is that kind of a central molecule that is then biotransformed into 5,10 methylene tetrahydrate and the methylated folate. So it's a rate limiting step. So remember I say that all these cycles are connected. So the folate cycle, the side, if you're going to look to the left of the folate cycle is how we think about it. You have the biopterin cycle, which is where you're seeing BH2 and BH4. This cycle is really, really important for how we produce dopamine, serotonin, and also our catecholamines, and break them down. And it's a very, very interesting cycle. But what I want you to pay attention to here is that this cycle, the biopterin cycle, interacts with arginine. So a substrate to producing nitric oxide in the orange circle is BH4 and arginine. So BH4 plus arginine in conjunction with endothelial NOS, which is nitric oxide synthase, produces nitric oxide. So in other words, there's a connection all the way from folate to the biopterin cycle to producing nitric oxide. What's the connection then? So why would I even mention this? Because I said if you go all the way back to folate and B12, and we're going to stay on this slide, one of the things, a substrate for the methylation cycle is homocysteine. Inefficiencies in folate absorption, metabolism, and folate absorption and utilization, availability of B12, one of the kind of the hallmarks that isn't working is an elevated homocysteine. What is the impact of elevated homocysteine? And this is the aha. And then I'm handing it over to you really fast here, Ashley. So homocysteine, what can it do? Elevated homocysteine, number one, can downregulate something called mTOR. mTOR, some of you are familiar, is like activates autophagy. So in other words, autophagy is like how we clean the cell. There's a connection between the efficiency of autophagy and elevated levels of homocysteine. But very specific to this slide here, elevated homocysteine can actually activate something called ADMA. It means asymmetric dimethylarginine. And don't you love that, ADMA? ADMA will actually inhibit, in short, this entire process. So if you think about it, elevated homocysteine will activate ADMA. ADMA will actually prevent or shut off the production of nitric oxide. And as a result of that, actually put in action or put into place this pro-oxidative process, which in the end will result in a very oxidative, stress-driven environment. And when we think about nitric oxide, we think about cardiovascular health. In this case, the connection then here, thanks, because I wanted to show that graphic to put this in place. When we're in a very pro-oxidant environment, which results from an elevated homocysteine, activating this ADMA, what happens is that induces oxidative stress. Along comes our LDL, and we have the perfect storm where we have a pro-oxidative environment, LDL, we oxidize LDLs. LDL is a base constituent for plaque. If you want to know more about what I just talked about, it's absolutely amazing science. Hopefully we can pop this citation into the chat, but it's called, what was that called? Go back one slide, and then I'm jumping off here. There it is. The metabolism is
And I
significant. So
put in,
homocysteine.
yeah, we just need to
You
run,
did?
we need to move on to make sure we're on time, but we are going to
Okay,
put
sure.
all of the citations into the Facebook group. We're just using that as an easy way because I know sometimes we don't all get our emails. So once you
Sure.
get everything you need from there, for everyone who's listening, you are more than welcome to pop out. It just was an easy way for us to share everything with you without sending a bunch of emails. A lot of
Good for
things
you.
coming up and a lot of the questions. So Amanda, I'll cruise direct here so that we can.
Yeah.
I'm running late on how do we actually make us do that. That's okay. It's brilliant. It's so brilliant. So is our human body. And so, what everyone here we're saying is like, I mean, we learn this stuff, by the way. I mean, who couldn't, I'd love 27 more hours with Amanda to dive further into this. And many of you are, as deep and in this. And for some of you, it's like, whoa, is this even in my scope of practice? Or, how do I take this down to what I'm seeing in the questions? What supplements? What do I do if somebody's got high this or low this? How do I know, what about folic acid versus folate foods? So what I want to do now is show you why are we going through all the education? Because what people are being sold and how people are being treated is not personalized, is not doing this work, but you have the opportunity to do that. And you have the opportunity to do that at every scope. So we're talking to, I saw a range of different practitioners in here, which I love. So of course, we may be people who are doing testing. We may do things like getting a CBC, maybe we do stool tests, allergy, intolerance tests. We may look at somebody's genomics. And that is going to highlight for us, we're going to be able to reveal important data, especially with genomics, we're going to see that, once in their life, right? And then we need to understand epigenetics and certainly all the lifestyle factors. But when we see these inefficiencies and even deficiencies, we understand, we can understand how the genes impact active metabolites. We can also, Amanda points this out, and I think this is so in her teaching, I think this is so important, which is to reveal nutritional strengths, right? That's going to be really important. We want to play to somebody's strengths. We don't always want to look at, what's going wrong on that part. Someone's asking for an email, and we will be providing that at the end. So stick with us. We're going there. Clinical deficiencies, your MCV, homocysteine, we can identify things like absorption and nutrient sources that are going to be better and maybe what's not better. But what this information does not tell us that we all need to know, we need to know the root cause, what's going on within there, which genomics may tell us a little bit about it, but we also need to understand then how. How do we optimize this for the individuals? And this is your competitive advantage, because right now what's happening for people is they're going online and seeing, direct to consumer options where they can get their blood tested or their genomics tested and told what they should eat. They're circumventing you, the practitioner. And that's not better, but we have to explain to them why you are so essential. And that's kind of frustrating, but we've got to do it. That's the space today. We want to make that easier for you. And we also want to make it easier for you to really look at their total nutrition and be able to optimize that part. So to get better results, we need better information at the beginning. We all understand intake forms, but we actually need that better information all along the way. And I'm going to show you how it's much easier and effective to be able to do that. I like to say that we are actually their Uber and their Lyft driver. Please borrow that from me. So instead of a company or buying a supplement that says, oh, I'm a vegan, I should buy this multivitamin. Absolutely not. You are the person, you're Amanda or you're Ashley, and you happen to be plant monogamous. We'll get into that in a minute. Here's what that means for you based on your genomics, based on what you're eating, all of these different pieces. And so we need to see who they are, their foods, their fortifications. One of the things we're going to point out here is how valuable it is to start to have people look at packaged goods and processed foods in a different way than we've normally been talking to, and then we've currently been talking to them about it. Drinks, supplements, lifestyle preferences, health goals. Currently, where do they want to go? What is their current health and what's their past health, and what does all of that mean? So how do we figure out, this is what they really want to know, and this is what you specifically can help them with. So if they are plant-based, awesome, because what we're going to see is there's a great way to get in so many of the nutrients that we were talking about, zinc, magnesium, and all of these different Bs. However, There are also a lot of times where if you're plant monogamous, and it's not just B12, we're going to take a look at choline, we're going to take a look at some of the other B vitamins and see that you actually may not be meeting your gang of B needs based on your diet. And are you actually willing, even if you are plant-based, are you willing to eat this to get them in regularly? And then also, oh, by the way, let's debunk one of the big myths out there that nutritional yeast is a good source of B12 or B6 for you. Well, sorry, of folate. Well, it could be, but it's a fortified version, right? And so while you're getting your B2 and your B6, what about getting your folate and your B12 from a fortification? Is that going to be better for you? Amanda was just pointing out, you've got to go through that two-step process, and that may actually be a challenge. It may actually be something that's not better for someone. Let's flip it the other way, and let's say you're doing all meat all the time, or you're all fat all the time, or you're focused on paleo, or you're just getting rid of carbohydrates or doing lower carbohydrate. Again, this is for you to work on with your patient, but especially if you are trying to attract new clients or you're trying to work with them, meet them, remember you're their Uber or their Lyft driver at any phase, you're going to pull up and you're going to say, all right, if this is you, let me show you something. You are actually not meeting your gang of B vitamin and choline needs with your current diet, and I'm going to show you based on your current food intake and supplements. And also, by the way, you may be taking in some of these nutrients, but are they quality sources? And also, how is your digestion? We're going to need to know that. What if I'm fasting and I just am now trying to shrink what I'm eating into a tighter time period, or have certain low calorie days, and I'm going to be doing that consistently? How does that affect my gang of B vitamins and choline needs as well? My digestion, we've talked a lot about that, but it's going to be so important. Little typo here, but my medications or my medical conditions, are they affecting my B vitamin needs? Do I have elevated homocysteine? Do I have a lipoprotein A, and a family history of heart disease? Do I have a history of bariatric surgery? Am I taking methotrexate? Am I taking, on and on? We need to know these pieces, because yes, the answer is they do affect the needs. So you want to point out right there to anyone, whether it's on Instagram, in emails, or in in the information that you share with their doctor, so that their doctor refers over to you. Or if you are the doctor and you're making that referral, you want to point out all of these things need to be looked at in totality to optimize your needs. Of course, your genomics are going to affect it. How are we going to talk to them about that if that's within our scope of practice and our knowledge base? Deficiencies and insufficiencies. One of the greatest problems right now are multivitamins and B complexes that just dump all the B vitamins in there. So Amanda and I text each other on a regular day. Yep, another person, or even ourselves, that are high on B6, right? So what's going on if we're trying to get a better balance in here? How do we optimize that? Think of things like magnesium and calcium that we've learned about how we need to maybe stop having certain things or reduce our intake, especially from a supplement form, to optimize a better balance. Super critical with our gang of Bs plus cousin choline. And then very importantly, to look at a range of different life stages. How is it going to affect your needs? What shifts do I make in my nutrition? What's doable for me? It may even be as the seasons change. I eat differently from a seasonal standpoint. So what does that mean in terms of my intake? So we need to know it all, and we need to know it all the time. We don't get to step in there and just do a one-off assessment, do a genomic test, do a blood work, and then be done with that. And what we need to teach our clients is that we're on this road trip with them, right? So why do I use the Uber and the Lyft analogy? Is because I'm going to pick you up and I know where you want to go, but if we're driving along and suddenly there's a lot of traffic, I want to be able to help you there, right? So what do we want to do? Well, first we want to show them very specifically where their current nutrition is either satisfactory and better, yay, or where it's insufficient. And that's going to help us with our supplement discussion. And it's going to help us be able to say to them, hey, this is how I do a total nutrition recommendation for you. If we come in here, it's very easy to see that, not a lot of people might be, especially if you're following more of a plant-based diet, might not be eating beef liver or ground beef or roasted chicken or your fruits, some of these fruits and vegetables. What if I'm avoiding beans? What if I don't, I'm allergic to or intolerant to nuts? What if I just don't know about some of these seeds? But at the same time, what if I'm getting in a bunch of these fortified foods, right? So the new pantry upgrade that you can do easily is you can turn around and actually have them go into their pantry to find where there's folic acid in there. You know what? That's going to be a lot better than just telling telling someone to reduce their intake of highly processed foods or of packaged foods. You're going to be able to show them here why we're trying to improve their folate status as opposed to folic acid fortification in these foods. When it comes to choline, really helpful to see that, you know, if I'm trying to get closer to 500 milligrams, and that my needs might even be higher than that, that's a lot of eggs I'd have to eat in the day, and I have to eat the yolk, and I want a good quality egg. And you know, in terms of tofu, that's several cups of tofu, or and maybe I'm avoiding soy, or you know, here's what I'm doing from it's 7 ounces of salmon for 150 milligrams. You can see how easy it is to be insufficient from a food standpoint in our intake of these nutrients. When you see this, and when your client sees this, and when the collaborative practitioners that you are sharing this information with see this, it is so easy to show your clients what steps, what are their better next choices, and where are we going to go from here. What's also great to show them are efficiencies, play to their strengths. There actually are a lot of commonalities between B2, B6, folate, less so when we get to B12, but there are a lot of commonalities there, and that's going to help you develop a specific meal plan for them that helps them optimize their total gang of B vitamin intake. Many of you were asking about the different forms of supplements and how to assess the B vitamin supplements. Also, many of you might have clients who are wondering, you know, who drink alcohol, or maybe they're looking at, you know, should I avoid dairy, or I currently avoid dairy. When you ask these questions, as well as the health questions, you know, anything from pregnancy to epilepsy to IBS to dementia, any of these medications, are you taking these? Do you personally know if you have any of these SNPs? When we have all of this data in one place, you get to show them what is affecting their needs, and then you get to show them, based on their current nutrition, what is better, but what also needs to be better. And that allows you to create a personalized plan. Now, we create that plan once, but then what we don't do is just give that to them and send them off and say, okay, that's great. We're going to have you, you know, try to increase this and do these things. No, if we go back, what we actually need to be doing, and why we're building a relationship with them, is that we're going to be assessing, choosing what they need to do, and then we're going to be tracking it. So what you can do in there is every 3 weeks, every 4 weeks, you can come back and have them fill this out seasonally. You can come back if they're getting their cholesterol and their CBC and other things tested. You can send this over to their doctor if you're a dietitian, naturopath, et cetera, and you're sending somebody over for another practitioner, or if you are their doctor, you can look at this and see, based on this in complement with their lab work this year, what has gotten better, or hopefully it's more like every 6 months on that part. And when you're asking about what are better recommendations, so first of all, assessment is in every practitioner's scope. But if you don't have the information on how to personalize these recommendations, we wanted you to have that. We want you to know when you might want the adenosine, or when you might want the phosphatidylcholine versus the phosphatidylserine, or when you want to. So we include for you, as a separate tool, or 2 different versions of this evaluation, the recommendations that show you, based on the information that you're assessing, based on how your clients are filling it out, what's for consideration in there and how you may use that. And why is that important? Because what's happening for everyone out there is they are hearing things, like maybe because of 23andMe, or maybe they're hearing the word methylation out there, or My Gene Food, or one of these other tests that are out there that are direct to consumer, and they're thinking if they just take a methylfolate supplement instead of having folic acid, they've done what's right for their genes. That is not going to be what is better for them at that space, and you're going to be able to show them why that's not what's better for them. It doesn't help if you just change the form of the supplement. We have to do the rest of the work, as Amanda was so articulately and in depth and just so fascinatingly showing us earlier. It doesn't help us if we just improve the methylfolate recommendation as a supplement. We've got to go in there, we've got to audit their folic acid, we've got to know about their magnesium, we need to see what their zinc is, we need to know if they're getting in enough choline, we need to know if it's okay to supplement with choline, etc. And how are we able to do this? We're able to do this using just one tool, along with a lot of others. Now, how does this help you overall in your business? I'm not going to go into too much of this because we're running out of time. I can talk about more about it tomorrow, but I do want to point out that you can use this as a way to attract clients. You can step in and explain to them that unlike what they're being advertised to, there is actually something that's better when it comes to their Bs. It is important for them to understand that it's how the nutrients play together that's better, and it's not necessarily what's in their multivitamin. You can use this in programs. You can use this for as a lead magnet for DNA or micronutrient testing. If you are somebody where your scope of practice is better used to use this as an assessment to then have them do that pantry audit for adults and kids on that part. If you're working in better energy, better brain health, better heart health, optimizing fertility, in all of these places and more, we need to be talking to them about their B vitamins on that part. So we want to invite you, most importantly, to make sure that we've got time to answer any of your questions. Those links are below. I want to just go through a bunch of questions that came up about that. The session tomorrow will be recorded. It will be in the Facebook group for you to be able to access that. If you have any questions, go ahead and drop into the Facebook group and ask those questions now, and we'll make sure that myself and Amanda are answering those. If you are interested in getting the evaluation along with 100 others, so you can look at magnesium, you can look at calcium, you can pull it together under eye health, brain health, heart health, digestive health, and have those. You also, Fullscript is one of our favorite partners. Because you came to us through Fullscript, we actually have a 15% off discount that's only available for 72 hours. So you would use at checkout for any of the memberships to get the shop of tools Fullscript 15, and you can head over to the website. Anyone who purchases in this time will also be having exclusive first access to a special session this fall with Amanda, who has the launch of her genomic practitioner program, and we'll be talking more about that tomorrow as well. So in conclusion, the most important things that we can and should be doing is that we need to be changing the conversation about B vitamins. We need to first of all be shifting conversations away from is your multi better because it just has cobalamin, or we're upgrading cobalamin to methylcobalamin, we're upgrading folic acid to methylfolate. That's not going to matter if somebody doesn't have adequate choline. It's not going to matter if they don't have these other nutrients. It's not going to matter if their diet is hyper processed and is a significant source of folic acid. It's not going to matter if the rest of their diet is not meeting their other nutrient needs, protein, these other pieces. So what does that mean? This is an opportunity born for you all. Every one of you that is here today, and those of you that are listening to this at a better time for you, this is an opportunity for you where it can show them. You don't have to tell them. You step in and you show them how you as the practitioner are there, you're on this journey with them, because throughout their life, these changes, there are going to be shifts. And when you understand both at where their body currently is, their health, and then when you have all of the data about what they're eating, you can actually have them avoid mistakes like just quickly making changes and trying something new based on what they read about this hair, skin, and nail vitamin or these other pieces. So with that, I want to thank Fullscript. We have all of your questions written down. We have people are asking about, yes, absolutely, very high doses of methylfolate. People who are on folic acid with methyltrexate. Which supplements should you be choosing? All of these, we are going to be answering that tomorrow, as well as on Thursday. Those are live opportunities, but we also will be recording those on that part. How do you get into the Facebook group? You just need to request access, and we will go ahead and approve that access. Do please fill out the questions there. Just that's how we approve people. You can just let anyone know that, so my team knows that you are part of this conversation today, and you'll be able to get in there. Great questions. What form of folate to supplement with? It might not actually be the best question. We might actually need to know based on, you may have several different situations where you're like, okay, this is why this person needs a folate by itself, or this person needs a folate, a B6, a B12, or this person, would do well with methylfolate, but we also need to audit their pantry to make sure that we're not getting in other folic acid sources. So we want to make sure that we're personalizing these. Thank you for asking about high selenium. We'll be answering that part as well. absolutely right. Sometimes methylcobalamin can make people feel hyper or isn't the best for somebody who maybe tends towards a degree of anxiety, et cetera. We will be talking about that as well. Oh, I love the questions that are coming in. Thank you to everyone. I want to be conscious of your time. We borrowed 3 minutes into your next hour. So I will go ahead and end this. And on behalf of Amanda, myself, and Fullscript, the Genomic Kitchen and the Better Nutrition Program, thank you so much for joining us today. And we look forward to seeing you tomorrow live or on Thursday live, otherwise getting you that recording. You will also be getting the recording of this session. We will also in the Facebook group be putting the citations. We will not be sharing the slides. I want to be really clear about that. Several of you were asking on that part. The slides will not be given out. And thank you so much for everyone who is saying that they enjoyed this. Yes, and there are issues with everybody being taught all of these things. Great question. So the Zoom time and the Facebook time are all East Coast times. So we're using EST, apology on that part. You can get the vitamin chart, absolutely. This is where you go to get all of those assessments. And there's a link in the chat box right now to the preview tools where you can actually see the tool and see what you're getting. When you purchase these, you get lifetime access to them. So they are tools that are designed to help you. And you do not need to sign up for the Zoom tomorrow, for the Zoom on Thursday, or for the Facebook on tomorrow. You just need to come in, and if you can't make the Zoom, I would recommend joining the Facebook group. The other option is if you have any further questions, please go ahead and reply to any of the emails. You'll be getting an email from the Better Nutrition Program, so please be looking at that. If it's not in your main inbox, it may be in your junk box. We will be sending one out this evening with the recording and with the links again to register for these 2 sessions. And we will send one out each day in advance of the session so that you have those as well. Any questions, hit reply there or ask us in the Facebook group. I'm going a mile a minute because I'm trying to answer this. Oh yeah, do you use intermittent fasting with some of your clients as one of your tools to optimize autophagy? Absolutely. However, your window of timing doesn't matter unless you've got the nutrients dialed in. We'll be talking more about that tomorrow. All right, everybody, that's it. Kaylee, thank you so much. We're really grateful. I think we can go ahead and close this down. Thank you.
Yeah, thank you so much, and enjoy your day, everyone.